Okay, welcome to Introduction to Solving Trigonometric Equations. These examples are in your booklets, your trigonometry booklets, and there are a few of them. I've worked through two just because I've got to be quite quick. So the first example here we go through is solve the equation cos of x equals square root of 3 over 2, where x is any angle between 0 and 360 degrees. So that is any and every angle between 0 and 360 degrees. So hopefully we are familiar with, in order to get the first angle, I would do cos to minus 1 of the square root of 3 over 2. And that gives me 30 degrees. The calculator will only ever give you the closest angle to 0, so we have to find the alternatives. So remember, cos angles, alternatives go up in 360 degrees. You can add and subtract your original angle. So 360 minus 30 degrees, which is 330 degrees, would also be a correct solution there. So 360 plus 30, which is 390 degrees, would also be a correct solution, but it would be outside our range there, so we don't bother with it there. So those two, 30 degrees and 330 degrees, are the solutions between 0 and 360 for that original equation, cos of x equals the square root of 3 over 2. Now if you want to pause the video and have a go at the next two examples, that's totally fine. And I'll talk through them now in a bit. So if I were you, I'd have a go and then compare what you have with what I have here. So example 2 is to solve the equation tan of x equals negative root 3. Be careful here that you are looking at a range of negative 180 to 180. So when you start off by doing your tan to the minus 1 of negative root 3, you get an answer of minus 60 degrees, which usually would be out of range, but in this case is in range, so it's okay. You can take that as one of your answers. You need to use it anyway to find your alternative angles. Alternative tan angles go up in 180 degrees and add every single time. So 180 plus negative 60, which is 120 degrees, is also a correct answer. If you went up to the next 180, so 360 plus negative 60, which is 300 degrees, that would also be a correct solution, but it's outside of our range, so we don't bother with that there. So negative 60 and positive 120 degrees are the two solutions between minus 180 and 180 degrees for that equation. Similarly, in example 3, sine of theta is minus 0.2. So when you do sine to the minus 1 of negative 0.2, you get minus 11.54. Now that is outside of our range because in this example we are looking at angles from 0 degrees to 360 degrees, but we still need to use it to find the alternative angles. So sine angles, alternatives are given by, if you go up in 180 degrees, subtract the first time and add the second time, and subtract and add, then add, subtract and add, keep going, alternate between subtract and add your original angle. And so the two solutions are given there by 191.54 degrees and 348.46 degrees. Okay, the reason I rushed through those is because I wanted to look at these equations where the angle isn't just an x or just a theta. Now that plus 10 is inside the function. Don't move it. You're not allowed to move it. It's inside the function. It has to stay there. So you will have to keep now your angle as x plus 10 degrees, and that will be given by sine to the minus 1 of negative 0.5, which is apparently minus 30 degrees, which, yes, is outside of our range, but we need to use it to find the alternative angles. So we now need to find the alternative angles of x plus 10. So we still are looking at our original angle x plus 10 even when we are finding the alternative angles. So remember, for sine, it's go up in 180s, take away, then add, take away, then add, take away, then add. Keep going. So 210 degrees, and x plus 10 can also be 360. Add minus 30. Now be careful, even though your 360 plus something is a negative angle. So that actually gives you 330 degrees. So it's when I have found my alternative angles now, can I find the values for x that I need. So therefore, x can be 210 subtract 10, because 210 was a value for x plus 10 there. So 200 degrees is a value for x. Similarly for x is 330. I need to subtract 10 to get 320 degrees there. Now notice I didn't bother with the original one there, that minus 30 degrees, because even when I subtract 10 from it, there's going to be minus 40 degrees, which is way out of the range 0 to 360, so I can just ignore it. So I need to find the alternative angles first for x plus 10, and then subtract the 10 right at the end. There. So don't touch that 10 until you've found all of the alternative angles, and then you can subtract it. Okay, similarly then for the final example, now this is to highlight the fact that any number on the outside of the function, so that 3 there, that can be moved, that's totally fine. This 2, however, is inside the function, is part of the angle, you don't touch that. So that 3 can move to give us cos of 2 theta, that 2 stays where it is 1.8 divided by 3, which is 0.6. That's totally fine to do. Any number on the outside is free to move. So I actually now need to find 2 theta, which is my angle, and that's given by cos the minus 1 of 0.6, which apparently comes out as 53.13 degrees. Now that is a value for 2 theta. Now originally I am looking for values of theta between 0 and 360. So because now my angle is 2 theta, I will in the end need to divide by 2, but I first need to find the alternative angles. The same as with the x plus 10, I found the alternative angles first before I subtracted 10. So it's wise for me to widen the range of my angles to satisfy 2 theta first. So because it is a 2 theta, I will have to go twice as high, because eventually I will be dividing by 2. So now then, I need to find all of the alternative angles for 2 theta. Remember cos is 360. You can subtract and add. Keep going up in 360s. Subtract and add your original. So when you subtract, you get 306.87 degrees. 360 add is also an alternative angle. That gives you 413.13. Now because these are values for 2 theta, I can also go up to the next 360 degrees, which would make 720, and I can subtract 53.13, which gives me apparently 666.87 degrees. 720 plus 53.13 would also be a correct answer, but it would be outside of my range when I divide by 2, which is 720 originally, but 360 is my value there for theta. So when I divide by 2, or if I did 720 add 53.13, that would be greater than 720. So even when I divided that by 2, it would be larger than 360. So these now then are all of my possible angles for 2 theta. So I will now need to divide them all by 2. So I can do 53.13 divided by 2, which is 26.565 degrees. Or the 306.87 divided by 2, which gives me 153.435. And again, even these larger ones now, the 413.13 is outside of the range, but I need to divide it by 2 because that was a value for 2 theta, and that is 206.565. And the other one was 666.87 divided by 2, which is 333.435. So all of these values are within the range 0 to 360 degrees. So any number on the outside, fine, free to move. Any number on the inside is part of the angle. In this case there was a 2 theta, so I've got to keep it as a 2 theta. Find all of the alternative angles for 2 theta first. Remember, your range, go twice as high because you're looking for 2 thetas, and then divide by 2 at the end. So find the alternative angles for your 2 theta first and then divide by 2 at the end. There is a quiz just linked under the video here if you want to answer that now before the lecture. Make sure you've made your notes, make sure that you've been through these examples and that they make sense to you. Thank you very much.